Patterns and linear functions.
So we are going to identify and represent patterns that describe linear functions.
Linear means line.
Yep, makes a line.
There you go.
And I'm guessing that they remember from 7th grade, constant rate of change.
You got it. We've talked about that quite a bit. So you're going to need to fill in the definitions for function and linear function.
So go ahead. It's written right on the screen. Go ahead and take some time.
Not.
It's not?
Why? Why is this not?
Well, let's define it then. A function.
Oh, it's on the next page.
Oh, okay. So here we
Hang
go.
tight. Okay, so we're talking about dependent variable, independent variables, inputs, and outputs today.
Input is X, output is Y.
You got
I just want to give you that.
Yep.
Okay.
So here's the definitions you need to write down. So function, a relationship that pairs each input value with exactly one output value.
Exactly one. You cannot have X equals 0 and Y equals 1 and 7.
Right.
That would not be a function.
Right. And so here's our little diagram for that. Here's your input. You put it into whatever the function is. Then it comes out as one
Output.
Guy. Okay.
Love it.
So linear function.
That's not
Red
going to work.
marker. A function whose graph is a non-vertical line or part of a non-vertical line.
Okay, so here's why I know that it cannot be vertical. Because this is X, right? This is my X value. If this is X equals 1, I've got all these values of Y. And we just said you can only have one value of Y.
Correct.
So this could be a function.
Yeah.
This could. No.
No. Got it.
Okay. So.
Representing a linear function.
Okay.
The table shows the relationship between the number of photos, X, you take, and the amount of memory, Y, in megabytes left on your camera's memory chip. Is the relationship a linear function? Describe the relationship using words, an equation, and a graph.
Okay, we can do this.
Okay.
Here we go.
Now, you can't really see this graph on your table, on your notes. We know that, but it's right here on the video.
Or if you want to take a minute, you can pause it and write the numbers that are on the video right on either side of your notes right there.
Also in your book.
Or it's in your book. Okay. No, actually, I can't find it in the book.
Oh, dang.
It must be one of the extras.
No.
Oh, it's right here. I found it. Okay. So the amount of so what's the first thing you want us to do?
Well, we know the amount of memory left given the number of pictures taken shown as the table.
Okay.
So if you take 0 pictures, you have full memory on that card. If you take 1 picture, well, it dropped down by a few.
Used 3.
Yep.
It looks okay.
So
It looks like
so
it uses 3 megabytes per picture.
Okay.
Which is my rate of change.
So it'd be -3 over 1. Okay.
Okay.
You need other representations that describe the relationship.
Okay. We just talked about that.
Yep. In the plan, look for a pattern.
That you can describe in words. Make a graph to show the pattern. So
We just did that.
we just did that. So do we need to write this stuff out?
Yep.
Okay.
So we just did this. So this is +1. And we saw that this was -3. Okay.
And it's really important that you actually write the minus because it's a decreasing relationship.
Correct.
Okay. So in words, the amount of memory left on the chips is 512 minus the quantity 3 times the number of photos taken. So again, if I wanted to know how much I'm going to have left after 3 photos, I don't want to have to, or 20 photos.
Yeah.
Good grief.
Right.
I don't want to make a table all the way to 20.
Right.
I just want to know that for every picture, it takes 3 megabytes. So if I do 20 pictures, that's going to be 60 megabytes.
Right.
Because 20 times 3. So I would subtract 60 from 512.
So coming up with these words, that's the hardest part.
Yep.
Is making this real life situation into a math sentence.
But once I've got the math sentence, I can easily translate it into numbers and symbols.
You
so
got it.
512 minus 3x, x for photos.
Yep. Y for memory. So memory is equal to what you start with minus 3 megabytes per picture. And that's how we just came up with this.
Okie dokie. So again, it's just writing a linear equation.
Yep.
Okay.
You can graph it.
Yes. We're graphing this particular situation.
Yep.
So we need to plop our stuff on there.
Okay.
So x, y, and our title.
Okay. What comes first?
Title is
Camera memory.
We're taught what this is all about. So memory on the camera. My x was number of photos. Yep. And my y
write
was
this in.
Memory. Or you could write memory left would make sense too, but
Yeah.
memory is fine. So now I started with 512, and I know. Do we even want to talk about y equals mx plus b yet?
No.
Okay.
Well, we're in.
Okay. So I started at 512 with 0 photos. So I'm
Okay.
gonna pop that dot on there.
So Do I need to label this?
Yeah.
So
What do you wanna go with?
25?
Sure.
Can I fit it? 25,
Ooh, I don't think
50, 100,
25's not
No.
gonna fit. Let's go by 50s.
50. Here, even
Go by
better.
hundreds.
So 100, skip.
200,
200, skip. 300, and 400,
500,
and 500.
and 600.
So I went by 50s, but I only labeled my 100s. That's what happened here. Number of photos.
How many do we have to go up to? I think it was only like 3 or 4 on the
So I
graph.
can go by ones.
1, 2, 3, 4. Oh, that's gonna make a dinky graph, but that's okay. Yeah. All right, so 0 photos. I had 512 megabytes.
Okay, so go up to 500, a little more, make a dot. So it's not specific at 512,
You're-
but it's a general.
Right, you're estimating.
Mhm.
Okay, and then I know that at 1 photo,
Okay,
it went down 3 megabytes.
so to 509, I think.
Mm-hmm.
Okay,
So that's why I feel like we should have made this a bigger.
okay.
But that, I mean, well, oh shoot, sorry. Go ahead and erase.
Sorry. Like this?
Yeah. Okay.
This way it's not a scrunch.
That yeah. So that way it's not. You're not. Yeah. Okay. So then 1 photo had like 509.
Okay.
Then 2 photos had 506. And 3 photos had 503.
Oh, geez.
Mm-hmm. And 4 photos had 500.
Oh, geez.
So it'd be right on that line. Yeah. So that one needs to come up just a tiny bit.
Okay.
So again, it is showing a linear relationship.
Right,
Because it does make a line. It decreases the same amount each time.
right.
We would not connect the dots at this point because you can't have half of a photo.
Correct.
And I think you're good. That's the end of this situation.
Okay.
That's it. So now we're going to check.
Done.
Do you know that this is a linear function? It should have exactly 1 output for every input. And then what is an equation that describes the relationship? So find your rate of change, and you're good.
There you go.
See you on the flip side.
Later.